Oh, good morning, good afternoon, good evening. We'll be getting started briefly here. Um, can you all in the chat just let me know if you can hear me? Perfect. Thank you, John. Thanks. We'll go ahead and get started at about 11:03. Just give everyone a few more minutes to continue to join in there. So I appreciate you all joining already, and we'll get started shortly. Rick, we're right about that time. So again, I appreciate you all joining here with me today. Excited on this topic here. Um, yeah, so we'll go ahead and get started. So with this, we want to dive right into how to simplify pH. So with us, being a manufacturer of our pH sensors, to us pH is simple. But as you outlined in this, you really want to be able to highlight that to you and to all of your customers as well, just how simple pH really can be and how you can present yourself as an expert to your customers in just 20 minutes, right? So if you follow some of the steps that we walked through today, you'll be able to present yourself as an expert. Whether you're an expert already or you're new into the game and you want to be able to present yourself with that level of confidence, and this is for you, and this training should help you be more effective in demonstrating the value of a pH sensor in the market. So again, kind of the overview here. For those that don't know me, I'm Ryan Flood. I'm the COO here at Water Analytics, the maker of the AquaMetrix instrumentation. So as we go through this webinar today, please feel free to add questions or comments into the chat as well as we go through. We'll end with a question session at the end of this presentation. So we'll go through from there. Otherwise, we'll just walk through the presentation here and then open up for questions at the end. We like to start off with the importance of the reliability of an AquaMetrix pH sensor, right? So look at this really harsh, really rough environment where a lot of sensors just aren't going to last, right? So this is a pH of 2.5. You can see here, for lack of a better term, it's just a dirty environment. And this pH sensor, with maintenance, with calibration, it's lasted for over 10 years and it just keeps working. And that's really what we stand by with our pH sensors. So when you start off your conversations as you're talking about the AquaMetrix pH sensors, the fact that it just continues to work is really key, right? It's the instrumentation that works when you need it to. And all of you know just how important that really is in the industry. When you have a sensor that doesn't work, you have other downstream processes or other implications that depend on that reading. You need that sensor to work. You need that sensor to be reliable. And that's what we stand by with our sensor. So you right out of the gate, something you are able to show to your customers or something that you're able to be bought into as a customer is looking at that picture, right, was just how robust these sensors are, and they continue to last year after year and continue to work for you and your applications. What are the other keys to impress, right? So saying it's reliable, showing pictures of it, it only goes so far, right? There has to be more to that sensor that really brings you in, to brings your customers in. And to me, the three real keys to impress here are going to be the simplifying on the installation, the rebuild, don't replace. And that's going to be really, really key to our differential sensors. And then how to assess the sensor health and perform calibration, again, in a really simple way. I'm going to say simple a lot throughout the presentation today. And it's because I stand by it. That's really what we're trying to deliver here today, is just to help you guys realize how we can make these sensors that, yes, are calculating the science behind the scenes without going into those details today, without showing a periodic table, without doing anything, behind the scenes of the science. You can still demonstrate the value of the pH sensor in its simplicity. What are the important basics, right? And install. That's how you start off with your pH sensor. So yes, you have to win the sale, or you have to buy the sensor if you're the end user here. Really where it comes down to is day one, you're unboxing that and you're installing it. It's a really important fundamental for our sensors and any sensor. And where it starts with is, how do you wire it, right? I'm sure some of you have been to a site or you've had someone, be to the site, or you're with someone as you're trying to do your startup. You just can't remember how to wire the sensor. You may be looking at a lot of different sensors, maybe looking at a lot of different wiring, and the expectation isn't for everyone to have every single sensor memorized of how to do it. We try to make that simple. So all of our sensors coming out of the box are going to have that nice little QR code that's going to have what that wiring is. You can also see where it is here. Here's the kind of generic wiring for your applications, depending on what controller or PLC that you're going to be connecting your sensor to. Knowing where this is, having this picture on your phone, a nice printout as you get ready and arm yourself for that install is really important, right? No one wants to be on site and say, I have the sensor, I'm ready to plug it in, I just can't remember how to do it. And that's where having a little trusty QR code or saving a picture on your phone goes a long way. And again, starts to highlight that you're that expert. It's not that you need to memorize, that black is ground and red is the process on the P60. It's more that you're able to pull that up and be able to demonstrate that. So now let's talk about the general installation. There's a lot of different ways that sensors can be installed. And today I won't go through all the different applications in which someone may try to install, because that is going to be unique for you and your customers. And it's going to differ most likely from site to site with maybe some subtle nuances. What we want to highlight today is that when it comes to mounting, we've got you covered. We have different solutions that may work best for you, whether it's a T, a wet tap, a sanitary flange, a jet cleaner, or even a guard. We have different applications for our different sensors that allow you to work best for what that install is. And where it comes into highlighting yourself, being that expert, it's asking that question up front of either yourself if you're the person using the sensor, or for your customer if you're representing a customer and you're one of our partners. What it will allow you to do is ask that question of how should this be installed? What is your intended use for this sensor? How do you want to operate? Understanding some of those questions is going to allow you to pick the right accessories, the right mounting to allow a nice seamless installation. Because if you install it the wrong way, right, you try to use a T when you want to put it into a wet tap mount, it's just simply not going to work. Right, you need flow for the T, and you need a valve to be able to access for the wet tap. There's little subtle details that you need to be able to be aware of, and it all starts with kind of asking the question. We have the documentation to help you all with that as you go more forward into that installation. Because at the end of the day, installing a sensor when you've thought through it at the beginning can be really simple and easy to execute. Other ways to really highlight how you can be an expert. Angles matter, right? The way that you're installing it in the site is really important as well, given how the pH sensor works. You want to be able to have it, kind of in that vertical installation, or a slight angle off the horizontal line will allow you to have good readings throughout the life of the sensor, versus putting it completely horizontal or upside down could cause some issues with your readings, and simply not having it in the process at all can be an issue. Now you may think, well, that's kind of a silly example there, but it does happen. Sometimes people will install a sensor in a location where it's just not even touching the water. You have to make sure that you're thinking through the whole application with it, and again, asking those questions either of the install site or of your end customers, and understanding how they're going to be using it, and making sure that when it goes to get installed, it's flawless from the get-go. And installing in the right, proper fashion will allow you to install it in and be ready to go and start running and getting your pH readings right out of the gate. Now this is the really exciting value that I like to talk about with our pH sensors. It's rebuild, don't replace. So for those of you who have been in the pH industry for a while, or are familiar with pH sensors, a lot of you are probably used to that culture of sensor stop reading, throw it in the trash, grab the next sensor off the shelf, plug it in, and move on with your day. But a lot of times, right, those sensors are hundreds of dollars every time you're going to be going forward with that approach. Versus, could you just move forward and get a nice new salt bridge? So you can see here, I can take my salt bridge off. Here, move this. In just a few seconds, I've got my salt bridge taken off. When this needs to be replaced, you're going to throw this in the trash. This is just around $30, right? Compared to hundreds of dollars for a sensor. You take this off, dump out your solution, reference solution, pour your new reference solution back in, and it's as easy as just re-screwing that the new salt bridge right back on, and your sensor is rebuilt, right? So as I'm talking through here, in less than a minute, right, as long as you've got your screwdriver handy, you're ready to go, and you're back up and running. And you don't even need to take out the wiring with it, right? So in some facilities, that can be a real burden where you need to have an electrician to be able to do your wiring. Not everyone can do it. Whereas with a salt bridge, any person that's trained to do that, who's trained to use a screwdriver, can replace the salt bridge. You see the sensor there, again, really simple in terms of that. You're just taking that salt bridge out, replacing the reference solution, and now your probe can last for years, not months. But there's also other features and advantages with this differential design. It's not just that you can replace it. The sensor is going to last longer as well because the electrodes are not getting poisoned, right? With these double junction electrodes, sometimes in some of these harsher environments, they can be poisoned and they need to be, again, thrown out on a more regular basis. There was one site we went to not too long ago where they honestly couldn't even tell us how often they were replacing it because it was just second nature to them of, every week or two, one of their sensors wasn't working. They would throw it out, put a new sensor in, and move on. When we started talking about this rebuildable solution instead of replacing it every time, their eyes really lit up and they were excited about this opportunity. They just weren't aware of this. And so this is something that we can really start to highlight into the market here of just how simple that is, right? Again, all you need is your screwdriver, take the salt bridge off, and you're ready to go. So how else can we simplify your expertise? Well, it's going to come through calibration and electrode health assessment. So I know it's a bit of a mouthful there, but we'll start with our calibration process here. And really where this is going to come from is there's a few different ways you can perform calibration. And I'll talk through kind of the most simple way that we like to do it here at Water Analytics. Well, let's start first with how a dirty sensor can mislead you, right? So again, in a really harsh environment, here's a great example. This sensor, the customer was having a hard time with this one operating. But the real issue with this one is there's some important features on your sensor that just simply need to be clean, right? So it's going to be your glass, right? If your glass electrode is covered in some sort of residue or biofilm or something, it's just not going to get reads, right? That's kind of your fundamental when you look at it is look at the glass. The glass is covered and you can't even see the glass, as you can kind of see in this picture. You're not going to get proper readings. Same thing with the junction. If it's covered here on the salt bridge, again, you're not going to get proper readings. And when you look at that and say, well, now do I have to replace that? No. Cleaning is easy with this. The basics, you start off, you just do a little brushing or wiping. Right? You can use a nice soft bristle toothbrush. It may be silly that you're bringing a toothbrush with you, but for those of you, again, who've been doing this for a while, you probably do have a nice little toothbrush in your tool bag. And again, just simple, clean, wipe it down, and it's probably ready to go. For a little bit more dirty, you can go with a nice DI rinse, and even more kind of on the extreme of the dirtiness, a nice little weak acid wash, depending on what your application is, right? Obviously, you need to think through what acid will work for your application so you're not mixing improper chemicals. But for the most part, really simple acid wash will work, and they'll get your sensor clean and ready to go. So back to calibration. So now when you look at it, you can grab your favorite water analytics controller, whether it's the 2250, 2250 TX, as I show in the picture here, or the 2252 like I have here in front of me today. These are really designed for simplicity to walk you through your calibration process. We also have calibration standards here. There's many of them available on the market. I'm sure most of you who have a pH sensor at your facility or are servicing customers that have pH sensors have these in an abundance at your facility to be able to walk through your calibration processes. So with this, and I've shown in a few other presentations in the past, there's a few different ways you can perform calibration, whether it's on a PLC, whether it's on our 2300, or on our smart sensors like the PTX, directly onto the sensor with a computer. I won't walk through all of those processes today. Want to highlight the one walking through with our 2250 series. So we'll start off. For those that may not be familiar with it, this is going to be that screen when you first get into it. You go ahead, you're just going to hit menu, you're going to come here, and you're going to go and choose calibration, right? So you can kind of see here, I've got the controller here. I've also got the slide up just to make it a little bit easier for you all to see it. So you'll just simply go through this process. You'll hit your calibration button, and then you're going to choose what you want to do. So you want your 1 point, 2 point, 3 points, or you want to calibrate temperature. For the sake of the demo today, I'm just going to do the 2 point calibration. That's really the preferred methodology when it comes to pH calibration. You can do a 1 point calibration. It's not highly recommended. Some people will do it, but really the majority of installs and the most recommended approach is going to be your 2 point calibration. If you want that extra precision, then go ahead with your nice 3 point calibration, right? Again, we offer 3 different calibration standards, 4, 7, and 10. So your 3 point calibration can easily be done with those. And all it takes is just the extra time to do that last solution that you won't see in it today. I'll walk through with just 2 standards today and just show you just how simple that will be. So as soon as you've got your sensor plugged in here, you'll have it there, you'll put it in, and then you'll go to your choices here of auto calibration or manual calibration. For the sake of this demo, I'm going to go through the auto calibration really to highlight just how simple this is going to be. Your manual calibration is going to be very similar to the auto calibration. It's just going to give you a little bit more flexibility in terms of choosing what standards you have. So again, as I referenced, we have 4, 7, and 10 as our standards. Some people prefer 9, some people prefer 6. Again, most for the industry is 4, 7, and 10 is your standards. And auto calibration knows that and it'll actually have some ability to detect which solution you're putting it into as a reference solution. Manual calibration will just remove that and you'll just manually enter it in. So it's a little bit slower, but only by a few seconds. What you'll do first, you take your sensor, you go ahead and put it into your first buffer solution. I'll choose 4 here as my buffer solution. And it's going to auto detect that I have 4 as my buffer solution. Again, that is the beauty of this auto calibration, as I put it into 4 and it knows that it is 4 based off of its readings. Now, if it's doing the auto calibration, a nice little trick here, right, is if it says this could be 7 or this could be 10 and you have it in 4, it may indicate that you need to perform additional maintenance, which I'll walk through a little bit later. But if you're putting it in and the auto detect is off, what it actually can help you do is stop the calibration process earlier and move over to the maintenance section. Because if it's the auto detect says you're way off, then you know that you're wasting your time performing the calibration. You have to perform some of the additional maintenance beyond just that simple cleaning I talked about earlier. So after you've done your first solution and you've recorded that, you're going to go ahead and put it in your second buffer solution. So here I'm going to put it into a buffer solution of 10. Give it a little bit of time to get there, and then go ahead and I'll do the next one. It detects there was buffer solution 10. Once I get it, I believe it's stabilized. I'll go ahead and hit enter to continue. And that's it. It's now calibrated, right? But what it's giving you here is some information in front of you. And for those of you who have, again, been in the industry for a while, this is probably familiar to you of what your slope is and your efficiency and your offset. Now, you can know what the slope is and what your ideal slope is supposed to be for millivolts per pH, but you don't need to know what the standard is. What you really want to know coming off of this is the numbers there of efficiency and offset. These are really important numbers because what they'll help you do is help going into assessing the health of your sensor. For purpose of this, I'm going to go ahead and accept these. Then I'll talk about what this means by assessing the end of life of your sensor and determining when you need to perform more maintenance. So really simple here, right? If it's between 0.88 for your slope that's calculated off of it versus your efficiency, so that'd be 88% to 112%, it's all good. Anything outside of that, you should look to perform maintenance. And again, maintenance is as simple as I showed you here, right? You're going to replace the salt bridge and replace the reference solution. Once you've done that, you'll again have about 1 minute to do. Then you're going to move forward to recalibrating. Now note, if your offset is greater than 0.8 for a pH, that is a good indicator that you should replace your salt bridge. What I also have here is a nice little QR code that we have that brings you to a page on our website that allows you to enter these values in. So if you're not using the 2250 series that tells you the efficiency percentage, you want to calculate it itself. Maybe you're using a PLC or a different controller that doesn't tell you that information. We made a very simple tool, and it will tell you if it's all good or if you need to be performing maintenance. For post-maintenance, again, you're simply going to calibrate again. So you've already gone through the calibration process and you identified that your slope was off and your efficiency was off. And again, looking at these numbers, it's the slope of pH to pH versus the millivolt to pH slope that's red there, or looking at this as your efficiency. So again, if after you've performed your maintenance and you're back into that 88% to 112% range, you're good to go. That sensor is ready to perform, and you will get all the right readings you want to get, and your sensor can continue to perform for a long period of time after that. If after you perform the maintenance, right, you've cleaned the sensor and you've replaced the salt bridge, you've replaced the reference solution, and you're seeing values between about 75% efficiency, or just above 75% efficiency to 88% efficiency, or 112 to 125% efficiency, you can start to think that you're approaching the end of life. You still have time left on that sensor. It's not time to throw that out, but you may want to have one on your shelf ready to go as you move forward, or you may want to think about increasing your calibration frequency and maintenance frequency, because what it's indicating is that your sensor is starting to approach end of life. And again, as we showed with some of those pictures in the beginning, that could be years and years down the road, 10 plus years. But at some point, your sensor is unfortunately going to hit end of life. All sensors are going to get there at some point. Again, ours are going to last a lot longer from there. But as you start approaching that end of life, that's where you're going to have less than 75% efficiency or more than 125% efficiency. And that's where you want to start thinking about replacing that sensor. Now, again, depending on what your application is, it still can read. What it means by the efficiency is that you are going to lose some of your resolution, some of your accuracy within the calibration range that you've performed. And so you may want to just consider that in. Whereas if you're in the green or if you're in the yellow, you should have the accurate reading that you're looking for. So that's where we would typically recommend, if you're having your efficiency below those, is that's the time to start looking at replacing that sensor. But again, as I said, we have this impressive long life with our sensors, and for the most part, this is way down the road when you have to start thinking about end of life. And that the efficiency allows you to identify this as an expert to your customers or to other people within your facility, if you're an end user here, to highlight that you know when you need to be performing this maintenance, right? If you perform the simple calibration and you say, oh, now it actually might be time to replace that salt bridge, it gives you kind of that indicator that you need to do a bit more with that sensor to keep it running optimal for many years to come. And that's really what I wanted to walk through today. So as I went through this, right, in about 20 minutes, cutting out some of the intro, right, it really highlights just how simple you can walk through some of the basics with this. And really the nice simplicity of that calibration process in 5 minutes or less, you can really highlight how you can walk through that calibration and identify and assess the health of that sensor, right? Is it good? Is it approaching end of life, or is it there and it's ready to move on? But if you want to learn more about our sensors, more than just this quick run through of the simplicity behind them, please do reach out to our sales team or check out our website and look at more information there. Again, we're always happy to walk through and talk more about our sensors, whether it's really in depth from the technical end, or if it's, again, talking about how our sensors can help solve the problems for you. We're here to talk through any of those with you and anyone on your team. I appreciate all of you coming to this webinar today. So I'll open up to any questions that any of you guys may have here as we approach the 30-minute mark. Obviously, if anyone needs to drop off now, I appreciate you joining, but I'm here for any questions that any of you may have. Bill, I see your hand raised there. I can unmute you. There you go. All right, Bill, you should be able to unmute and ask your question if you like. While Bill's working on that, any other questions from anyone? Feel free to add questions into the chat if that works. Looks like Ray here, you got a question, so let me go ahead and allow your mic. All right, there you go, Ray. So you should unmute and ask your question if you like.
Also, I'm ready. Yeah. Hello, it's Bill Dalala. Hello.
Seem to be working there. So again, if you guys have questions, you can add in the chat, but otherwise I'll let you guys all have a little bit of time back here. I appreciate, again, all of you guys joining today. And again, remember, pH can be simple, and you all can be great experts in highlighting the advantages of the differential pH sensors into the market and really demonstrate yourselves as that expert and just show how simple pH sensors can be. But again, if you need anything else or want to hear more from us, don't ever hesitate to reach out to us here at Water Analytics. We're always happy to help you. And again, thank you all for taking the time to join the webinar today. All right. Have a great rest of the day.